recording now. And let's go ahead and get started here. So multiplication, division of integers, integer multiplication models. So it says multiplication of integers is approached through a variety of models. One of them is the chip method, one of them is the number line, and then there's some patterns. So let's take a look here at what we're gonna do for the chip model. So it says, the chip model can be used to illustrate multiplication of integers. It says, look at the first picture where 3 times negative 2 is using the chip model. So the product 3 times negative 2 is interpreted as putting 3 groups of 2 red chips in each, okay? So when we have 3 times negative 2, we're taking 3 groups of 2 red chips, because remember the red chips were supposed to be the negative ones. Now, the next part here, y'all, says, look, to find negative 3 times negative 2, negative 3 is taken to mean we're going to remove 3 groups of the negative 2's, okay? So if you notice, they have 3 groups of the negative 2's, and we're pulling those numbers out, okay? And so what are we left with? We're left with a positive 6, okay? Okay, so just a quick reminder. I mean, I know we've all gone through this over the years, but rules for multiplying integers, y'all. So positive times a positive is positive. A positive times a negative is negative. A negative times a positive is negative, and a negative times a negative is positive. And those same rules, y'all, apply for division as well. Okay. So we're going to go through a couple of problems here, see if we can't figure this thing out. So it says use the chip model to show the following. Negative 4 times negative 2. Just to give you, just a reminder, y'all, what this part means is we're going to remove 4 groups of double negatives, okay? We're going to remove 4 groups of double negatives, okay? So I want you to notice in each of these pictures, y'all, they're kind of taking, right, there's supposed to be a little arrow there, but they're taking stuff out, okay? So what I want to do is I want to see which one of those removes 4 groups of the 2 negatives, okay? So if I look at, say, part A, well, I have 2 groups, right? And that's not what I want. I want to remove 4 groups, okay? When I look at part C, yeah, I have 4 groups, but I'm grouping positive numbers. So no, I don't want that one either, okay? When I look at this one here, I have 2 groups, right? Those are 2 groups. And when I look at D, look, I have 1, 2, 3, 4 groups, and they have the double negatives, right? So that's what we're taking out, okay? And so now, y'all, I know we know this because, you know, we've gone through these courses before, right? We've done math for a lot of our lives. But I know that a negative 4 times a negative 2, I know that's a positive 8. But I want to show you, using the chip model, how we get the 8 from here. If they take away those groups, look what we're left with. We're left with 8 positives, right? 8 little positive signs. So we know that's why our answer is a positive 8. Okay. Okay. Let's see. The next one is, I'm just going to scroll back up here because I want to look for something. Okay. Let's see. So the next one here, y'all, is 4 times negative 2. What this means is I want 4 groups of the 2 negatives, okay? So if I look here, y'all, I'm looking for the ones that have 4 groups. Well, A and D have 4 groups, right? They've kind of grouped those things into 4 chunks. But I'm looking for the ones that have 4 negatives. Now, the D has positives, so that's not what we're looking for. So I'm going to choose A. And I know that 4 times negative 2 is the same thing as negative 8, okay? All right, so give me one quick second here, y'all. I need to look something up. Boom, 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 boom. Okay, so now when we're going to do division, okay, when we're going to do division, what I'm looking at is this number here is going to be my total chips. And that -5 is going to be the number, oops, in each group. Okay, the number in each group. So the one that has -10 and the number in each group. So let's take a look here, y'all. I'm going to look at my choices A, B, C, and D, and I want to see which one has a total of -10s. Well, if I look at B and I look at D, those have the negative signs, okay? So I know it's not going to be A and it's not going to be C, okay? And then what I want to figure out is between B and D, the -5 should be the number in each group. So if I look at B and I look at D, which one has -5 in each of the groups? Would you say B or D? B does, right? Yeah, so B does, right? Okay, now again, y'all, just going with my rules of operating with signed numbers when I'm dividing. A -10 divided by a -5 is a +2, okay? All right, and this next one here where I have a -18 divided by 3, again, the -18, that's going to be my total. And then the 3 is going to be the number of groups, okay? The number of groups. So first thing I want to do here, y'all, is I'm going to look at which of these choices, A, B, C, and D, have 18 negatives. Remember, the negatives are the red ones. So it looks like A and D are going to be my choices, right? So I'm not going to look at C and I'm not going to look at B because A and D have the negative. There's a total of -18s, right? Or 18 negatives. Now the 3 tells me how many groups I'm going to have. So if I look at A has 3 groups, right? 1, 2, 3. Okay, so y'all, A is going to be my choice. What I'm looking at is what is the number in each of those groups? -6, right? -6. Okay, so that's the chip method. Now, y'all, there's another way that we can do multiplication, and it's using the number line. Okay, so it says, just as with addition and subtraction, we can demonstrate the multiplication along a number line. Here are the rules for walking. So we're always going to start at 0, okay, and we're going to face the positive or the right direction, okay? If the number is positive, we're going to walk forward. If the number is negative, we're going to walk backwards, okay? So let's take a look. It says, use the number line model to show that 4 times -5 equals a -20. Okay, so what we're going to do here, y'all, I want y'all to remember that multiplication is just the idea of repeated addition. Okay, multiplication is just repeated addition. So what we're going to do is we're going to move -5. So we're going to go 5 spaces in the left direction, and we're going to do that a total of 4 times. Okay, so I need to see, number 1, we always got to start at 0. Okay, so if I look at choice A, y'all, we're not starting at 0, like they kind of have it, so they're going like that, so that's not good. Okay, I want to make sure that I'm starting at 0. Okay, so I'm looking here. So guys, if I look at these things here, it looks like choices C and D start me off at 0. Okay, so I'm going to go 5 spaces to the left, and I'm going to do that 4 times. If I look at choice D, look, 5 spaces, 5 spaces, 5 spaces, 5 spaces. How many times did we do that? We did that a total of 4 times. And so there's my number line model to show that 4 times -5 gives me -20, okay? Again, I'm going to do it 4 times, but I'm going to move 5 spaces to the left. Why to the left? Because my number was negative, right? And I'm doing that 4 times, okay? Okay, so now let's take a look at this next problem here, and it says, the number of students eating in the school cafeteria has been decreasing at the rate of 30 students per year for many years. Okay, So first of all, y'all, when it tells me it's decreasing, that doesn't mean it's going up. That actually means it's going down. So I'm going to think of that 30, y'all, as a negative 30 because, again, it's decreasing, right? It says, assuming this trend continues, write a multiplication problem that describes the change in the number line of students eating in the school cafeteria for each situation. Okay, so the change over the next 5 years, okay, over the next 5 years, y'all. So remember, we're going to do this thing 5 more times, right? So 5 more times would be 5 times what number? Times negative 30. Very good. So if I look at my choices here, A, B, C, and D, which one would I pick? B, right? Good. Okay. Now, if they're talking about the situation 5 years ago, so I'm not talking about the next 5 years, I'm talking about 5 years back. Well, if I go 5 years back, that 5 years back would be a negative 5 and a negative 30, right? Because I'm going 5 years backwards. So now if I look at my choices, I'm going to choose part C, okay? Because I'm going 5 years backwards, right? So if I'm going 5 years backwards, it has to be a negative 5, okay? Now, part C says the change over the next n years. Now, y'all, this is kind of similar to what we did right here. We said, look, the change over the next 5 years was 5 times negative 30. So the change over the next n years is going to be n times negative 30. And I'm going to look at my choices and I'm going to say, hey, look, that looks a lot like choice C, okay? And then when I get to part D, it says, what was the situation n years ago? That's kind of like this one here. The situation 5 years ago was a negative 5. So the situation n years ago would be a negative n times a negative 30, and that looks like choice D to me, right? Okay, so y'all, for this next part here, it says evaluate each of the following expressions if possible. So remember, y'all, all I'm really doing here, I'm thinking about my order of operations, like parentheses, exponents, multiply, divide, add, and subtract, right? So back when we were in school, we learned it a lot using this PEMDAS idea. So remember, we have to do what's inside the parentheses first, okay? So we're going to do that. Excuse me. So let's take a look here. Negative 12 divided by a negative 2 is going to give me a positive 6 times a negative 4, and that's going to leave me with a minus 24. Okay. All right, for part B, I'm going to do it exactly the same way. I'm going to do what's in my parentheses first. 12 times negative 4 is going to give me a negative 48. And then I'm taking negative 48, y'all, and we are dividing that by a negative 4. That's going to give me a negative 12. This is part A. This is part B. Let's do part C. Okay, I have to do what's in parentheses first. So I'm going to leave this negative 16 alone, divided by, now notice we're adding here, okay? So look, y'all, negative 8 plus 8. If I owe you $8 and I pay you $8, we are now even Stevens, right? So now, y'all, I'm trying to take negative 16 and I'm trying to divide it by 0, okay? So one of the problems we have, y'all, is I cannot divide by 0. This gives me an undefined value, okay? All right, let's take a look at part D. I'm gonna do the same thing here, y'all. So negative 4 plus 4. If I owe you $4 and I have $4, part D, we are even. If I owe you $3 and I have $3, we are even, okay? The problem again, y'all, I'm dividing by 0. So again, that's going to be undefined, okay? And let me do part E over here on the side. I'm just going to rewrite it so that I have it here and I can do what I got to do. So that looks like the absolute value of negative 27 divided by brackets 3 and 6 minus 15, okay? So again, we're going to do our PEMDAS. We're going to work our way from the inside out. So the first part I'm going to do here, y'all, I'm going to do this piece. So I'm going to leave that 3 alone. Now remember what this means. That's a positive 6. That means I have $6, but I owe you 15. So if I have $6 and I owe you 15, I would still owe you $9, right? Because I owe it to you, it's negative. Okay. So look, I'm going to leave that negative 27 inside my absolute value alone. Okay. Still got to deal with some parentheses here. So we're going to deal with that. I got these brackets and these parentheses. So 3 times negative 9, y'all, is a negative 27. Now, what we're going to do is we're going to fix this absolute value part. Now, remember, a negative number is how much money I have. I'm sorry, how much money I owe, and a positive number is how much money I have. But the absolute value just says how much do you either have or owe. So I know that this means I owe $27. But the absolute value says, don't worry about the sign. How much do you owe? You owe 27. And 27 divided by another negative 27 would just give me a negative 1. Okay. All right, so let me scroll back this way so we can do the next one here. And it says, in the following, A and B are integers and B is not equal to 0. Okay. So it says, use the definition in terms of multiplication to perform the indicated operations. Write your answer in simplest form. Okay, so look, y'all, we have 6a, and we are dividing it by 6. Remember, division just means we have a fraction. So this 6 and that 6 are going to cancel out. I'm just left with the letter A. Okay. Same thing for the second part. Look, it's negative AB, so I'm going to write negative AB divided by B. Okay. And I'm going to do the same thing. Look, this B here and that B there are going to cancel out, and I'm just left with a negative A. Okay, so for my next problem here, y'all, it says, in a lab, the temperature of various chemical reactions is changing by a fixed number of degrees per minute. Write a numeric expression that describes each of the following if all times are on the same day. Okay, so look what it says. It says the temperature at 8 p.m. is 33 degrees Celsius. If it drops 2 centimeters per minute, what will the temperature be at 8 p.m.? Okay, so y'all, I have a question for you. If it's dropping, would my 2 be a positive 2 or a negative 2? Negative 2, right? Okay, good. Negative 2 per minute. Okay. Now, look, we know the temperature at 8 o'clock. We're trying to find the temperature at 8:10. How much time has passed between 8 o'clock and 8:10? If it's 8 o'clock right now, and then we're going to check the temperature at 8:10, would you guys agree the time would be 10 minutes? So look, we're going to take negative 2 times 10. That's going to give me a negative 20, right? Doesn't mean that the temperature is negative 20. It means that the temperature has dropped 20 degrees in those 10 minutes, right? So if the temperature was 33 degrees and it drops 20 degrees, wouldn't the temperature now be 13, right? Because it's gone down 20 degrees. Okay. Okay, so look, I'm going to look at the next part. It says the temperature at 8:20 is 1 degree Celsius. Okay, if the temperature has dropped 2 centimeters per minute, okay, I know that's still, or negative 2 degrees, I'm sorry, I still know that's a negative 2. The question is asking me, what was the temperature at 750? Okay, so y'all, just like we've done before, look, I know the temperature at 8:20. I want to know, what was the temperature at 750? Wouldn't that time have been earlier? It would have been going backwards, because from 8:20, if I want to go to 750, I actually have to go back. Okay, so the first thing I want to ask y'all, do you know how much time has passed between 7:50 p.m. and 8:20 p.m.? So look, y'all, we can do it like this. From 7:50 to say 8 o'clock. Wouldn't you guys agree that's 10 minutes? And then from 8 p.m. to 8:20, That's another 20 minutes. So we have a total of 30 minutes. But because it's earlier, I'm going to use a -2 and a -30 because I'm actually going backwards, right? So look, -2 times -30, y'all, that gives me a +60, okay? So what I'm going to do is I'm going to say, look, if the temperature is 1 degrees and I add 60 to it, my temperature is going to be 61 degrees, right? And you might say, why did you add 1 degrees? Because that's what the temperature was at 820, right? So again, I'm going backwards here, right? Because I want to know, I know what the temperature is at 820. I'm trying to see what was it at 750, because it was warmer at 750, right? In Spanish, we say antes, right? Before. Okay, look at part C. It says the temperature at 8 o'clock is -14. Okay, so look, y'all, I'm going to put 8 p.m. Temperature is -14 degrees. Okay, we're dropping. So my temperature is going to be a -1 per minute. What was the temperature at 725? Okay, so again, y'all, I want to know, look, from 725 to 8 p.m., how much time has passed? Anybody know how much time has passed? If it's 725, how many minutes do we need to move to get to 8 o'clock? Anyone know? 35, right? Good, perfect. 35 minutes, right? But take a look, y'all. If it's a temperature at 8 right now, and we're going to go back to 725, that means we're moving in the negative direction, okay? So look, -1 times -35 is a +35. So I'm going to take my temperature right now, -14, and I'm going to add 35 to it. Oh, let's see, let me turn this on. 14 negative, add 35, +21, right? So my temperature is +21. All right. And we have a next part here. We have a part D. Part D is in dog, and it says the temperature at 8 o'clock is 27 degrees. Okay, so let me write that down. At 8 p.m., it is 27 degrees. It is increasing every minute by 1 degrees. Okay, so that's a +1. Okay, what was the temperature at 725, right? So look, y'all, 725 to 8 p.m. Again, we know that there's a total of 35 minutes, but because we're going backwards, we're going to think about that as a -35. So I have 1 degree times -35 minutes is a -35. Now we have 27 because we started off at 27 degrees, and we're going to subtract 35. So again, I'm just going to use my calculator here, 27 minus 35, and that's leaving me with a -8. And so the temperature at 7:25 p.m. was -8 degrees, right? Okay, let's see. So it says, it was predicted that farmland acreage lost to family dwellings over the next 6 years would be $15,000 or 15,000 acres per year. How much acreage would be lost to the homes during this time period? Okay, so we have 15,000 acres per year, right? And so y'all, if we're going to have this number of acres per year and we're looking at 6 years, we're going to take 6 times 15,000. Okay. Again, I'm going to grab my calculator, 6 times 15,000. And that's giving me 90,000. Okay. Now, y'all, since it's acreage lost, I know I'm thinking about a negative number, right? Because I'm losing the acreage, but I'm not actually going to write a negative number here simply because when they use the word lost, that's emphasizing that it's going to be, it's really a negative, right? Because it's lost, okay? All right, so let me show you all how to do the next one here. When I was looking at this problem here, I was like, man, it can kind of get a little bit confusing just the way they write the process out. But let me show you the way we're really kind of work through this thing here. So it says, illustrate the distributive property of multiplication over addition by showing that that's going to be true when A is -1, B is -3, C is -2. Okay, so look, y'all, this is what I'm going to do. Where the A used to be, I'm going to put a -1, okay? Where the B used to be, I'm going to put a -3 minus, because there's a minus there, the number C, which is a -2, okay? And that's supposed to be equal to A times B, -1 times -3, minus A times C. So -1 times -2, okay? So they're asking me to show that this is going to be true, okay? So remember, y'all, a negative times a negative is a positive. So a -1 times a -3 is a +3, minus a -1 times a -2 is a +2. My question to y'all, what is 3 minus 2? It's 1, right? Okay, look, we're going to do the same thing over here. So look, just like we did before, y'all, remember PEMDAS? I'm going to do what's inside the parentheses first. Okay, so remember, a negative and a negative make that into a positive, right? So look, if I owe you $3 and I have 2, would you guys agree that I would still owe you 1? Right? And then a -1 times a +1 is, I'm sorry, a -1 times a -1 is a +1. Okay, so look, whether I do it on the left side or whether I do it on the right side, I still get one answer, 1, right? So right here, y'all, it says it's going to result on 1 on both sides, okay? All I'm going to do for this piece is I'm going to put the -1 right there. I'm going to put the -3 right there. I'm going to put the -2 right there. And then on this side, I'm going to put my -1 right here, my -3 right there, my -1, and my -2. And all I'm doing is I'm just filling in those numbers into those little boxes right there, okay? But again, I think the way they have it written in the boxes sometimes looks a little confusing and you're not really sure what you're supposed to do, but this is really what they're kind of asking me, okay? All right, so let's take a look here, y'all. The next one says the product of two integers is a -33. Okay, -33. I want to think of numbers that I know multiply to 33. So I know 1 and 33, and I know 3 and 11. But those numbers actually multiply to a +33, okay? We want to get a -33. So I know in order for me to get a negative number, y'all, I have to do this. Look, a -1 and a +33, or a +1 and a -33, or I can have a -3 and 11, or a +3 and a -11. So these are my choices here. And then what I'm going to do is I'm going to come back to my choices A, B, C, and D, and I'm going to do a little stare and compare and say which one looks like what I have in my red boxes, and I would probably say that D looks like it because -3 and 11, -11 and 3, -1 and 33, 1 and -33, right? So y'all, when you're doing a problem like this, you look at your choices and it's like, man, all those kind of look the same. Yeah, they kind of look the same, but they really aren't, you know? So you just kind of have to be a little careful when you're doing it. Okay, so let me keep scrolling along here. Excuse me. It says multiply each of the following and combine terms when possible. All right, so let's see what we can do here, y'all. So look, I have a -6 and then I have an F minus G. Okay. So all we're going to do, y'all, we're just going to multiply. Okay. So look, -6 times F, -6F. A negative times another negative is a positive, and 6 times G is just a 6G. So that was part A. Let's do part B. Okay, look, we have an F with another F minus G. Okay, F times F. Guys, if we have 2 of them, that's when we write F squared. Okay, a positive F times a negative G is a negative F with a G. I can't put them together other than just writing the 2 letters right next to each other. Okay. All right, I'm going to do part C. I'm going to do it exactly the same way. So look, we have a negative F times an F minus G. So I know an f times an f would give me an f squared, but because of that negative, I now have a negative f squared, right? And then a negative f times a negative g. A negative times a negative is a positive, and I still have my f and g. And then we have one last part, part D, okay? And let's see, we have a negative 6, and then we have an f plus g minus h. Okay, so I'm going to go 1, 2, 3. Negative 6 times f, y'all, is a minus 6f. Negative 6 times g is a minus 6g. And a negative times another negative is going to give me a positive, and that's going to leave me with a 6 and an h. Okay. All right, so y'all, for the next problem here, we're actually going to skip this one here. So I'm going to go like this, and I already pulled it out of your homework. You don't have one like this. This part here, honestly, I think it would be more for like an algebra type student, and you know, if that, it's maybe more like 9th grade type of math. So I decided to hold off on that one, okay? But let's keep moving along here. Okay, so it says in each of the following, find the next two terms. It says assume each sequence is either arithmetic or geometric. Find the common difference or the common ratio and the nth term. Okay, so let's take a look here, y'all. I'm going to look at choice A. Okay, so here's my sequence: -6, -3, 0, 3, 6, 9. I want to know, what am I doing from one term to get to the next? Does it look like we're adding something to each of those numbers to get to the next one? So if it helps y'all, just look at these parts. Okay, don't worry about those for right now, but look at these parts. What are you doing from 0 to get to 3? Or what are you doing from 3 to get to 6? We're adding 3, right? Okay, look, y'all, just to show you, we're really doing the same thing here. Look, if I owe you 6 and I have 3, I still owe you 3. If I owe you 3 and I have 3, now we're even Stevens. Okay, so this is what we call an arithmetic sequence. Okay, and the common difference is a positive 3 because we keep adding 3 to it. So look, y'all, the next thing says, what are the next two terms? If this is 3, 6, 9, what would the next number be? If we keep adding 3, what, 12? And if we add 3 again, that would be 15? Okay, now, yo, we talked about arithmetic sequences, but we talked about arithmetic sequences like either the first day or the second day of school. So it's been a long time since we've done it, okay? So first thing I'm going to do here, I'm going to show you the formula. So the formula says AN equals A1 plus N minus 1 times D, okay? So just so that you remember, this here, y'all, is the first term, okay? This here is the difference, okay? So look, this is how I'm going to write it out. I'm going to say AN equals, if I look at my sequence here, y'all, what was the very first number we had? -6, right? So look, we're going to put a -6. Plus, I'm going to leave this N minus 1 alone. Remember what we said our difference was? Our difference was a positive 3. So I'm going to leave that as a positive 3, okay? Now, they do want me to simplify a little bit here. So we're going to go ahead and simplify. Okay, what I'm going to do here, y'all, I'm going to say, look, AN equals -6. I'm going to multiply this 3 to both pieces. 3 times N is going to leave me with a 3N. 3 times a -1 is going to leave me with a -3. Okay, and then I just have one more step that I need to do. I'm going to leave that 3N alone, okay? But I'm going to put these two numbers together. Now, remember what we said? A positive number is how much money I have, and a negative number is how much money I owe. So if I owe you $6 and I borrow 3 more, I now owe you 9. And because I owe it to you, it's a -9. So this right here, y'all, would be how I would put my answer in right there. Okay. And I think, y'all, in my lab, all you really need to enter is 3n minus 9. I don't think you need to put the little a in. You're just going to put the 3n minus 9. Okay, so look, let's take a look at the next problem. I'm going to go through the same sort of process. Okay, so look, y'all, I'm looking at my numbers here. Does it look like we're adding or subtracting the same number each time? Because if I look at the difference here, it looks like we subtracted 1 to get here, we subtract 2 to get there, we subtract 4 to get there, we subtract 8. Okay, so I know it's not arithmetic, but let me ask you a question. Does it look like we're multiplying each of the numbers by 2? What do you think? Does it look like we're multiplying each of those numbers by 2 to get to the next one? -1 times 2 gives me -2. -2 times 2 gives me -4, so on and so forth. Okay, so when we would say here, y'all, this is a geometric sequence. And the common ratio, because that's what we have, is going to be 2. Okay. Okay, so now that we have that part, I want to ask you all a question. What do you think the next two terms are? Look, y'all, if we multiply this number by 2, wouldn't that give me a -64? And if we multiply that number by 2, wouldn't that number give me a -128? Again, I'm doing the same thing, right? I'm multiplying every one of those numbers by 2 to get to the next one. Okay. So again, we talked about geometric sequences, but again, it was like in the first week of school, maybe the second week. So I want to give you the formula because again, I wouldn't remember it. Okay, so this is my formula where this is still my first term, and that right there is our ratio. Okay, so look, y'all, I'm just going to fill in some blanks here. I'm going to say AN equals A1, the first term was a -1, okay, times R. What's my ratio? 2 to the power n minus 1. And this right here, y'all, is what I would enter in just right there. That's going to be my nth term, okay? Alrighty, so I'm going to keep scrolling along here because I think there's a little bit more. Here we go. Okay, so it says a scuba diver descended 665 feet in 19 minutes at a constant rate. Write this information using integers and give the change in elevation after each minute. Okay, so let's take a look here, y'all. My question to you, if we are descending, does that mean we're going up or down? We're going down, right? And he's a scuba diver, so he's going down into the water, right? So that 665, y'all, because we're going down, is going to be a -665, right? It took him a total of 19 minutes to get there. We want to figure out how much is he going down each minute. So I'm going to take this number and I'm going to divide it by 19. And I'm going to look at my choices here, y'all, and I'm going to say, look, that's choice D, right? And then I don't know if it asks, it says, which of the following represent the change in elevation each minute? It would be that one there. If it did ask me to find out what that was, I would just take my calculator and I'd say, look, what's 665 negative divided by 19? And we would say each minute he goes down by 35 feet, right? Okay, we're going to do the same thing here, y'all, for the next part. It says, look, the temperature in the town drops 4 degrees per hour, right? So it's going down 4 degrees. And it does that for 6 hours. So I'm going to multiply it by 6. It says, use an integer to describe the overall change. They just want to know, what's my overall change? A -24, right? So right here, you guys, I would just put a -24. It's going to go down 24 degrees in those 6 hours, okay? Yeah, that would be my answer right there, yeah. Okay. And let's take a look at the next one here, y'all. It says, your Sirius radio bill is $50 every month. Okay, you have set up an automatic payment out of your bank account. Right now, we have $615 in our bank, and we're not going to make any deposits or withdrawals from our account. Write this information using integers and give the net balance in your account after 1 year. Okay, so look, y'all, we have $615 in our bank. Okay. My bill is -50, right? It's a bill, so it's going to be taking away money. Okay. So I'm going to put a plus a -50, and I want to do this for a year. But since they're giving to me this in months, how many months are in a year? 12 months, right? 12 months. Good. Okay, so look, this is my total balance, all right, or my overall balance. Okay. This is my bill, and because it's a bill, it's negative. And because my bill is every month, it's times 12 months, right? So I would look at my choice right here. I would look at what I wrote out, and I would say, okay, which one of those looks like it's representing my answer the best? And I would say, hey, probably choice C, right? Now, again, if it says give the net balance after a year, so what would I do? I would say, look, that's 615 plus, let's see, what is 50 negative times 12 negative 600? Okay. Now remember what we said, y'all. A positive number is how much money I have. A negative number is how much money I owe. So if I have $615 and I owe you 600, wouldn't you guys agree that at the end of the year, I'm still going to have $15 left in my bank account, right? Hopefully I'm putting more money in my bank, but that's what I would have. Okay. So my next problem here, y'all, says a drought can cause the level of the local water supply to drop a few inches each week. Okay, so if it's dropping, y'all, that's going to tell me my number is going to be negative. It says, suppose the level of the water supply drops 8 inches every week. So the first thing I do, -8. It says, write this information using integers and compute how far it will have dropped in 6 weeks. So I'm going to take -8 times 6. That's going to give me a -48. Okay, now I want you to look at the way the question is phrased. It says the result is, so right here, guys, I'm going to put a -48. So it says the water supply will have dropped a total of, I'm not going to put a -48 here, guys. I'm going to put 48. The term dropped is already emphasizing that we're looking at a negative situation. Okay. So we don't say it drops -48. We just say it drops 48 because dropped is like the English word for it being negative. Okay. Okay, so let me go to the next one here, y'all. And it says the market price of a company's stock has dropped $2 an hour. Okay, so again, right here, y'all, I'm going to say, look, that's a -2. Why? Because it's dropping. Drops $2 an hour for 4 hours. Okay, so I'm going to multiply that by 4. That means it dropped a total of $8, right? So the result is a -8. So the stock fell. Again, because they're talking about fell, it just says it fell $8, right? I wouldn't put it fell -8. I'd say it fell 8. Okay. And the next one here, y'all, it says Uncle Bob has a debt of $3,600. Since it's a debt, would you say that's a positive 36 or a negative 36? Yeah, negative 3,600, right? Okay, it says his 8 siblings offer to pay off all the debt. So his 8 brothers and sisters say, hey, Uncle Bob, we're going to pay this for you. Write this information using integers and compute how much each sibling would pay. So I'm going to take that negative 3,600, y'all, and I'm going to divide it by 8. I'm going to look at my choices here, and it looks like my choice is D, right? And again, I would, if I needed to find the actual value, I'd take 3,600 negative, I divide it by 8. So each sibling is going to end up paying $450, right? And it looks like Uncle Bob was our last problem here, y'all, out of 5.2. So let me go ahead and stop recording. Let's see, let's come back this way and